Hello. In this presentation, we're presenting the final milestone of our project, Toxic Commons Classifier by Muhammad Hashish and I, Sharif Wisa. These are the contents of our presentation. We're going to define the problem statement. So toxic comments include a wide range of harmful content, including abusive language, insults, and offensive remarks that's meant to harass or threaten others. And this issue has led to the discouragement of many people from openly sharing their ideas and opinions due to their fear of receiving hate comments, which in turn negatively impacts their mental and emotional health. Our challenge in this project was mainly to effectively classify and detect toxic comments on social media and online platforms. Starting with the original baseline model. The original baseline model consisted of three models using TensorFlow. First of which is LSTM RNN model, and the second one was LSTM RNN model, but with glove embeddings. The first one was normal word embeddings, and finally a BERT model. All three models use the F1 metric score, and they were sequential models, except for the BERT model. So for the proposed updates, first, we wanted to fine-tune the hyperparameters in the original baseline model and implement different combinations of deep learning models and apply some data cleaning, pre-processing techniques we wanted to use different datasets and finally collect the results and compare them, and finally choose the optimal result. So Hajj will continue with the final model.
So now I'll talk about the final model. So as for our final model, we've introduced a GRU model, which is an RNN model, and we fine-tuned its hyperparameters, including the activation function, the loss functions, and the optimizer. And if we didn't change the optimizer, we changed the learning rates. And we used the same method, which is F1 score. And then the second model was a combination of models, with a combination between CNN model and an LSTM model. CNN and RNN model. We fine-tuned its hyperparameters. We changed the loss function learning rates, the dropout, the patients, and the metric, which the average value, either micro or macro, we changed it, and we collected the accuracies and plots to compare. And we had we've developed all, the final project out of these three, which is CRN and GRU model. This is a combination between CNN and the GRU model, and we fine-tuned its hyperparameters, and we used convolution one max pooling 1D layers. Why 1D? Because it's text, it's only one dimensional, and we've added GRU layers, and we also use the same metric, which is the F1 score. So this chart shows the original model. The architecture, the first one on the left hand side, on the left is the original model. We have data set, it's pre-processed, and the word embedding, it can be used, we can use the glove word embedding, that's why we've added glove, and then it enters the LSTM and output layer. The proposed update one, we've introduced a CNN model, and then we've added GRU model, and the second proposed update, which was better in terms of result validation scores, which was between CNN, a combination of a CNN and an LSTM model. So as for the plots and graphs, these are the basic graphs that represent the data sets.
The labels, six labels.
Yes, and we've already talked about them before in the last milestone. And these are some kind of old results. What's new here is that we've ran the BERT baseline model, and this is actually its plot. Actually, the baseline model requires a high computational power. We didn't have enough time to change its hyperparameters and see the effects of changing these hyperparameters, because the 4 epochs would take 2 hours. So we ran the baseline model and we tried to change it, but we didn't have enough time in it. And then these plots represent the bidirection GRU models, different ones. GRU model alone, and then this is the LSTM and CNN combination models, the validation F1 score and the validation F1 score. And then this one is the GRU CNN models with also different hyperparameters. On all the previous plots, we've changed hyperparameters, and each change is written in the title of the plot, so to make it clear. And then these are the tests that we ran after using the best CNN architecture that we've introduced. This specific CNN, we've labeled it as CNN Model 2. And this CNN Model 2 achieved the highest results that يعني, as a newly introduced architecture. And as for the demo, now I'll show you a video. Yeah, and that's a screenshot of the code, the saved model, the weights, and the saved tokenizer. And these are the probability after giving it an input. And I'll show you a video right now. As you've seen, the model works and loads the model as well as its weights and the tokenizer. So
So
now
for the conclusion and future work, in conclusion, after trying different architectures and hyperparameters, we found out that the hyperparameters that were used in the original baseline models weren't the best in terms of validation accuracy. And upon changing them, we found that the highest validation accuracy that we achieved was the LSTM model only, and the second highest one was using a combination of the CNN model with the LSTM model, which introduced 0.94 validation accuracy. The first one was 0.96. And what we learned from these experiments is that it was our first time to combine different architectures together. And we also learned how to use the virtual environments to run the code to utilize the GPU. For future work, we would like to try different architectures, different hyperparameters to see what we can, if we can get a better validation accuracy. And we want to have the chance to change the hyperparameter of the BERT model, since we're limited by time and it requires half an hour for running a single epoch. And for the members' contribution, these are the detailed member contributions of me and Hashish. Thank you so much.
Thank you.